Ahoy hoy, I'm Planarwalk, and happy Halloween everyone. Now recently Nathan Oakley has been saying about this thing called angle of attack, which he's discovered, apparently. And this conveniently makes objects look as though they're going over a curve. Now this is complete and utter magical bullshit, so that's why I'm Wizard Planarwalk, here to debunk this magical bullshit. Just a note, I am taking the costume off because it's annoying to have on for a long period of time. So let's take a look at what Nathan Oakley says proves his point.
So the angle of attack is essentially what causes things to disappear from bottom up. So in this example I've set a book at the end of this very long hall which they play table tennis on, so it's incredibly flat, and as you can see, as I lower my angle, the book disappears.
So the first thing worth mentioning is that floor is definitely not level at all. Only in the mystical land of Flatadia would that floor be considered perfectly level. Now people have said that Nathan needs to verify whether this floor is level, and I agree, but they've said that he needs to do it with a laser. Now if this is something to do with light, then a laser is obviously not going to verify it. What he needs to do is he needs to take a piece of string long enough to reach the camera and the book, and tighten it up as much as possible between those 2 points. Then he needs to take a camera and just show that the string is roughly the same amount of height off the ground the whole way. If he can do that, then we can assume that the floor is likely level. If he can't do that, then I am not believing this for one bit, because it does not look level. And surely you'd think that someone like Nathan Oakley, who lectures people on independent and dependent variables, and who also lectures them on causation, would account for confounding variables. Just simply stating
at the end of this very long hall which they play table tennis on, so it's incredibly flat,
does not mean that the confounding variable doesn't need to be accounted for. Nobody who adheres to the scientific method would consider this proof. Even people doing the Cavendish experiment have accounted for confounding variables such as the electrostatic force. But Nathan, let's say your idea is valid. How does it work? Now, the most obvious explanation is that light refracts downwards so that you can't see it. And even I was surprised at how much sense this makes until you think about it for more than 5 minutes. If this were the case, you'd expect to see objects that are far in the distance that have begun to disappear from bottom upwards be less visible on cold days. However, this is the exact opposite of what we see. When it is cold, things like the Chicago skyline actually become more visible due to atmospheric refraction. This is due to light being refracted downwards. The reason why light refracts downwards on days like this is because the cold water cools the air above it. Cold air is denser than warm air, and because there is a gradient of cold to warm air above the water's surface, this causes the light to refract in the direction of the denser air. So if refraction was the reason behind the so-called angle of attack, you would expect to see less, not more, on cold days. So that's why refraction is not the reason behind it. And Nathan, before you accuse me of strawmanning you, I'm not. I'm just stating why one reason that you're likely to fall back on is invalid. That way you're actually forced to think about it for more than a couple of seconds, rather than coming up with the most obvious solution, which is easily debunkable. But, you know, I'm an open-minded person. If you can give me another reason, I'll think about it and see whether it's valid or not. And also, if you could work out the mathematical formula behind it, that would be brilliant. But I do wonder, do you need an R value at all? Leave a like and subscribe if you like that video. Leave a comment on what sort of video you'd like me to do next. You could also consider supporting me on Patreon if you want to help me out. But anyway, I will see you in the next video. Between you and me, thank you for watching. You know, normal people probably don't find this video very scary. But to Nathan it's probably terrifying. I mean, it's filled with logic and science and that kind of stuff. Nathan must be terrified.